experiment 8. Let's go ahead and look at our setup. We have battery switch. We have our 3.3 and 10 kilo ohm resistances. We have a 100 microfarad capacitor, our LED, and we have our wires connecting the circuit. As we hit our switch, LED turns on and turns off. It seems that it takes a little bit of time to charge and discharge. So now we will swap out our 3.3 kilo ohm resistor with a 1 kilo ohm resistor and see the difference that it makes in the circuit. So we swapped our 3.3 kilo ohm resistance with a 1 kilo ohm resistance and kept our 10 kilo ohm resistor the same. As we hit our switch, the light charges much faster and takes about the same amount of time to discharge, which gives us the indication that it is charging through the smaller resistance, the 3.3 and 1 kilo ohm resistor, and discharging through this 10 kilo ohm resistor, which has remained unchanged in this circuit. So now we will go ahead and swap out the capacitor for a smaller capacitor and see what effect that has. And as we hit the switch with our smaller capacitor, our 10 microfarad capacitor compared to a 100 microfarad capacitor in our original circuit, we hit the switch and the light both charges and discharges much faster now. This indicates that the smaller capacitor just requires less current to charge, and it discharges faster because it holds less of that charge. So what this essentially implies is that the capacitor is being charged charged through the smaller resistor and discharges through the larger resistor. As we increase resistance in either one of these, it would either increase the charging time or increase the discharging time. And as we decrease our capacitance, it also decreases the charge time and discharge time, while other things are held constant in the circuit. So that is experiment 8.